Welcome to the next lecture on engineering materials. In this lecture, we will try to cover steel and its alloys. Steel is an alloy of iron and carbon having carbon percentage up to 2%. So, if you see the production of steel, you can see limestone, iron ore, coal and other scrap items. They are all put into the limestone is put into a sinter plant, then it gets into a blast furnace. Iron ore is put into the blast furnace and coal is also added there. So, from here what do they do is they try to the output is put into a basic oxygen vessel. From there what they do is they try to get the molten steel. The secondary steel making process is also like this. So, where in which the steel scrap is put into an electric furnace, from there it gets into the secondary steel making and then you try to make a billet or whatever it is. So, you get this and then you try to make a steel. So, from a scrap also it gets recirculated and then you try to make use of it. It may also contain steel contains iron and carbon. Apart from these two, it can contain a small amount of chromium, nickel, cobalt, vanadium. The addition of these elements improve the property of steel. The addition of carbon increases the strength, that means to say hardness of the steel, as it forms iron carbide which have a high hardness. The formation of iron carbide will be dealt in one lecture when we talk about the heat treatment. The manufacturing of steel has several processes. On commercial basis, steel is manufactured by these processes: Bessemer process, open hearth process, electric furnace process, duplex process, LD process, then crucible process. Right? In electric furnace, you can have arc furnace, you can have induction furnace. So, the basic type of process used in steel manufacturing, the steel are named as Bessemer steel, electric steel, hearth steel and duplex steel. So, these are all the different steels which are available in the market. So, when we try to classify steel, so ferrous metal, steel, cast iron. The only difference in carbon content. When we have steel, we have wrought iron, then we have dead mild steel, low carbon steel or mild steel, medium carbon steel, you have high carbon steel. When we try to look into cast iron, you will have grey cast iron, white cast iron, malleable cast iron, spongy cast iron, you have spheroidal cast iron, then you have chilled cast iron, and then we have inoculated cast iron. cast iron are used, it has multiple classifications if you look into it, right. So, steel, ferrous metal can be classified into steel and cast iron. The difference between steel and cast iron is the percentage of carbon. So, we follow Huminary rules. See, what happens is when you try to have iron atoms in a unit cell, iron atoms in a unit cell, the size of the atom, the radius of the iron atom is larger than the carbon atom. So, there is a space in between these atoms. So, the carbon atom easily gets into the iron unit cell and then it occupies a space. So, these are all iron atoms, this is a unit cell. So, you can see how iron diffuses inside and goes and sits there. So, because of the property of the carbon to diffuse into iron, it easily forms an alloy. So, if there are more number of carbon ions, the movement of this cube is restricted. So, moment it is restricted, then you get cast iron. If it is less, then you try to have some amount of ductility. So, you will get into steel. So, that is what is the difference. So, how is this carbon getting diffused? It can be diffused using temperature or pressure. So, generally what we do is we try to do heat treatment, we try to take it to a higher temperature. So, the atom the cube slightly expands and then the carbon diffuses inside. Okay. This is the basic science. How is this alloys getting formed? So, moment there is a carbon which is formed, so it forms Fe or iron carbide, because the carbon sitting there, iron is getting formed. So, if you look into the classifications, when the carbon content is less than 0.05, it is called as wrought iron, which is Wi. So, you can see here, this is plain carbon steel, right, and here you see it is iron. So, from 0.5 to 1, it forms dead mild steel DMS. 0.1 to 0.3, it forms mild steel, which is MS. This is why we always call in colloquial terms we call it MS. MS is nothing but mild steel. In mild steel, you will have a carbon content up to 0.30, and from 0.30 to 0.7, we make medium carbon steel, which is MCS. And when we have somewhere from 0.7 to 1.5, it is called as high carbon steel, HCS. From 1.5 to 2, it is called as semi steel or semi iron. So, the transition happens between 1.5 to 2, there is a gray area, and from 2 onwards it forms cast iron, Ci, and from 4.5 to 6 it forms pig iron, Pi. So, anything more than 6.67, it is called as a ore. It has it is more than pig iron. So, it is very clear the steel comes only up to 1.5, and here the percentages is directly proportion to the. So, the hardness increases, the ductility increases when you go from down to top, right. So, these are the advantages you get, and the carbon is the major culprit. It is not only carbon, you have other additional elements also added to it. When we look at low carbon steel, they are generally containing less than 0.25 weight percentage of C, and are non-responding to the heat treatment intended to form martensite. So, austenite, martensite, so these things we will deal it later in our lecture, where in which we talk about heat treatment and formation of these structures. The strengthening is accompanied by work hardening. Work hardening is nothing but metal forming operations. Right. So, microstructure consists of ferrite and pearlite. These steels are relatively soft and weak, but have outstanding ductility and toughness. So, it can be used for applications like pipes, steel pipes, then it can be used for automobile parts, and it can also be used for domestic parts. For example, kitchen utensils and other things, it can be used. It can also be used for structural applications, frames, structural applications like tubes can be made. Okay. So, they are machinable, weldable and least expensive to produce. They can be easily rolled or forged to produce rod, bar, plate, etc., etc. Springs, the wires can be made from here. So, this is what is the microstructure when you look into the low carbon steel. We will have a detailed discussion about it when we are trying to do heat treatment. So, you will see ferrite structures are here, these are ferrites, and these are all dot like structure which are bainite, and these are carbon. When you take it to higher lower temperature, the carbon gets diffused. When we talk about medium carbon steel, the concentration of the carbon goes from 0.25 to 0.65. They can be heat treated by austenizing and quenching. They can be tempered to improve their mechanical properties. It has a shock, it is a shock resisting steel. So, for example, springs, right, good quality springs, leaf springs which is used in automobile are made out of it. The plain mild carbon steel have low hardenability and can be heat treated only in the form of very thin structures, but by very rapid quenching rate. So, when we are trying to do small amount of heat treatment with low temperatures and other things, then we always use a low carbon steel material. The addition of chromium, nickel, molybdenum improves the capacity of these alloys to be heat treated, giving rise to a varied steel strength to ductility combination. These heat treated alloys are stronger than low carbon, but by sacrificing ductility and toughness. So, the application can be spring here. Okay. So, when we are looking at high carbon steel, the high carbon steel normally contains a carbon up to 1.5 weight percentage. They are the hardest, strongest and the least ductile among all plain carbon steels. You see the ductility. When you go back and see my picture here, I have showed it, ductility, hardness, right. So, if you wanted to make it a very high strength material, a flat plate, so then we always go for high carbon steel. Some of the drills are made out of high carbon steel. They are almost always used in a hardened and a tempered condition. They are especially wear resistant and capable to hold sharp cutting edge, the drill bit, tools, the chisel edge, all these things are used of it. For example, the screwdriver tips, they are all made out of high carbon steel. The tools and die steel are high carbon alloys usually containing chromium, vanadium, tungsten and molybdenum. These alloy elements combine with carbon to form very hard and wear resistance property, chromium, vanadium and tungsten. So, here tools, cutting tools are made out of high carbon steel. So, when we look into the properties of steel, stress versus strain. Okay. So, stress which is in MPa or gigapascals, whatever it is, depending upon your requirements. Here it is percentage of strain, right. So, it is a unitless quantity. So, you can have then you can see varying steel properties. So, this is high speed steel, this is high carbon steel, this is mild carbon steel, this is mild steel, this is white iron. So, when you increase the percentage, increasing percentage of carbon. So, you can see there the stress increases and the strain reduces. When you try to see a typical tensile stress versus tensile strain, so you can try to have this is strong, this is weak, right, stress I am trying to, this is hard and this is soft, and this is only relative, this is for your just understanding. This is rigid if it goes like this, and this is elastic when it goes like this. When it goes like this, it is ductile, and when it goes like this, it is brittle. So, this is just a characteristics, right. Characteristics change of different materials. So, you will try to see that. So, in properties you should understand stress versus strain. How does the carbon content influence the stress and strain of the given material, and this is a typical characteristic change which is there. When we talk about alloy steel, an alloy is composed of two or more elements for which at least one element is a metal. So, you can have a base metal and a alloying element. The main constituent present in the alloy with highest portion is called as the base metal, and whatever is getting added is called as the alloying element. So, there are different purpose for adding alloying element in steel to form martensitic without cracking of steel. So, as I told you, martensite, austenite I will explain to you in the next lecture, to enhance hardenability, to enhance red hardness or hot hardness. So, for example, when we are trying to increase the temperature and check the hardness, when the cutting tool is cutting a workpiece, the temperature goes very high. The cutting tool has a very high temperature. So, now the hardness of the tool should not sacrifice. If it sacrifices, then it gets worn out. So, to increase the hot hardness, to distribute the carbide by tempering, to improve wear, corrosion and abrasive resistance, to impart toughness, to increase ductility, machinability and welding, and to achieve the overall improvement in the physical and mechanical properties, we always go for alloying elements. So, the elements can be silicon, chromium, nickel, it can be molybdenum, it can be magnesium, it can be manganese. You can add any of these things to meet out to the requirements. So, here are some of the alloying elements, here are their symbols. So, if you want to increase hardness, we add tungsten to increase hardness. To impart fine grain distribution, I told you in the beginning of the lecture itself, when we talk about grain engineering, we try to understand how do we make the grain such that we get the property. Chromium is to increase corrosion and oxidation resistance. Molybdenum is used to increase hardenability, making it hardenability. And then impart wear resistance is done by manganese, impart wear resistance. Titanium is to increase abrasive resistance, abrasion resistance. Nickel is to improve tensile and toughness. Phosphorus is to enhance machinability. So, that means to say easily we can machine the component. So, if you see that we have added different elements having different effect in the properties. When you draw a graph between hardness and alloying elements, you can see here by increasing the chromium percentage what happens to the hardness, then what happens by adding the property for phosphorus. So, you can see how is the influencing hardness with varying elements. The classification of alloys. So, when we try to classify the alloys, steel, so alloy steel, so it is low alloy steel, and then here it is high alloy steel. So, again here it is low carbon steel alloy, and you have high carbon steel alloy. Then you have mild carbon steel. In low carbon, you have high strength alloy, and you have free machining alloy. Right. In mild steel, you have spring steel and you have machinery steel. Okay. When we try to talk about high alloy, we have tool steel, we have heat resisting alloy, we have super alloy, and then we have stainless steel. Right. Again in stainless steel, you have ferritic, martensitic, austenitic, and then you have duplex. We will see this all these things in details later. So, here you can have super alloys, you can have inconel and mnemonic. And when you try to look at tool steel, again they have three classifications. One is water hardened, steel, then you have next is ordinary steel, then you have a shock resistant steel. So, these are the classifications of alloyed steel. So, we have used these things as references in this lecture. In this lecture, you would have seen the steel, alloys of steel and the classifications of steel in detail. The austenite, martensite, duplex, ferrite, these things we will try to cover in the heat treatment lecture. Thank you.